now we're going to take our lesson quiz to finish up this lesson. So question number 1, as the pressure on a gas increases, its temperature does what? So remember, in order to figure this one out, we're going to use our ideal gas law, that PV equaled NKT, so that as the pressure increases, its temperature increases. Okay, question number 2, how many neutrons does the average mercury nucleus contain? I don't know. So you have to get out your periodic table. So if you get out your periodic table and you look up mercury, which is Hg, it turns out that it has an atomic number of 80. So what did the atomic number mean? It meant that that was the number of protons. So it's going to have 80 protons. Can you see that? Okay, then if you look at the number that has the decimal point for mercury, it's 200.59. So that could be rounded up to 201. So what does that represent? That's the number of neutrons plus protons. So if we take 201 minus 80, what would that be? 121. So it's going to have 121 neutrons and 80 protons. And so when you add them together, you're going to get approximately this number right here. Question number 3. What is an isotope? So an isotope is going to be the same element, but it's going to have different numbers of neutrons in it. So if you recall, we talked about ordinary hydrogen had 1 proton and 0 neutrons. But another isotope of hydrogen had 1 proton and it had 1 neutron. So when you put them together, you get 2. So it would be hydrogen 2. And then there was hydrogen 3. That was tritium. So an isotope, it's the same element, but it has different numbers of neutrons in its nucleus. Okay, now question number 4. Where does the energy released in a nuclear reaction come from? Okay, so you could answer this 2 different ways. You could have said it's the missing mass after a nuclear reaction has occurred. Or you could have said that it's the energy that's being used to hold the nucleus together, so the binding energy. Which part of the sun is visible from the Earth? Okay, that was called the photosphere. Which part of the sun is where the nuclear reactions are taking place? That was the core. And then which part of the sun is convecting? Well, that's pretty easy. That's the convective zone. Okay, number 6, how hot is a sunspot? So if we go back up into the notes here, so this will take a while. A sunspot is 3,800 Kelvin. Pretty hot. So hot that the gases would be blinding to look at. Well, that's it. So we're finished now with this lesson on the sun. So in our next lesson, we're going to talk about properties of stars in general. So we're going to be interested in a star's brightness, its temperature, its color, its mass, and then eventually we're going to take all of that information and we're going to put it onto a sheet called the Hertzsprung-Russell diagram. And so I'll see you in the next lesson. Bye.